Hey guys, so today for geometry, we're going to continue analyzing and focusing on properties of quadrilaterals, right? So in the last class, we analyzed properties of parallelograms, what they are, what they look like, and the characteristics that their sides and angles have. Today we're going to be analyzing three other types of quadrilaterals, right? We're going to be focusing on analyzing the characteristics of rectangles, squares, and rhombuses, right? And those three, we're going to focus on just those three. Now I know for a fact that all of you have heard about rectangles and squares. I don't know how many of you have heard of rhombuses, but it's nothing too difficult, right? So we're going to start analyzing these characteristics. First one that we're going to analyze is a rectangle, right? And when we're looking at a rectangle, we know that we have a four-sided figure, right? Four-sided figure, four-sided polygon called a quadrilateral. Anytime we have a quadrilateral, it always adds up to 360. And the main characteristics of a rectangle that's separated from the others are that opposite sides are congruent, right? So if this is congruent to the bottom, right? We put one tick mark. So if that's 6, that would be 6. And the left and the right are congruent to each other, right? So we put 1 and 1 to show the top is congruent to the bottom. We put 2 and 2 to show that those two sides are congruent, but that they're not necessarily congruent to the top and the bottom. They could be, but a rectangle, only thing we know is that opposite sides are congruent, right? So if this would be 6, that would be 6. If this would be 5, that would be 5, right? That's one of the main characteristics of a rectangle. And again, it's the same as a parallelogram, in that opposite sides are parallel. These two sides will never intersect, those two sides will never intersect. But the main difference between rectangles and all the other ones are these two differences that we're going to focus on. For a rectangle, opposite sides are congruent, but then all the angles for a rectangle, they're all right angles, all of them. So that already right there is the main difference between a rectangle and a parallelogram, is that a rectangle, all of the angles, they have to be right angles. They have to be 90-degree angles, right? All of them, right? They're all 90-degree angles, which is why we represented it with that box there. So if we're dealing with right angles and opposite sides congruent, that will be a rectangle, right? And again, we know 90 plus 90 plus 90 plus 90 gives us 360, property of a quadrilateral. So a rectangle, remember those two things. Opposite sides are congruent and all the angles are 90 degrees, right? So we have a rectangle. Then we have the characteristics of a square, which the square is the one that everybody for the most part understands when they see it, right? Automatically, when we have a square, we know that all four sides are congruent, right? They're all the same. So one tick mark, one tick mark, one tick mark, one. The difference already right there between a square and a rectangle is that square, all the sides are congruent, but a rectangle, only opposite sides are congruent. So literally, if this is 6, all the other sides would be 6, right? And the same thing as a rectangle, all of the angles, they're all 90-degree angles, guys. All of them. Every single time we have a square, all the angles are 90 degrees exactly. They're all right angles. So the difference between a square and a rectangle, they have all equal sides. For a square, a rectangle only has opposite sides congruent. The way that a square and a rectangle are the same, they have right angles, right? Both of them, they have to have right angles to be a square or a rectangle. And then we have a rhombus. And the best way that I can explain a rhombus to you, a rhombus is almost a combination of a square and a parallelogram, right? A rhombus is a lot like a square and a parallelogram. So we have the way that a rhombus looks. But what I mean about a rhombus being like a square and a parallelogram, it's alike to a square in that a rhombus, all the sides are congruent. Just like a square, all the sides of a rhombus are always going to be congruent. They're all going to be the same. That's 5, 5, 5, 5, right? But it's alike in a parallelogram, one, in the way that it looks, but two, the characteristics of the angles, right? So what we know about a rhombus is only the opposite angles are congruent, right? So if that's 100, this one here is going to be 100, right? Opposite angles are always going to be congruent. One curve and one curve to show them the same. These are going to have 2 and 2, right? To show again that these two angles are congruent to each other, these two angles are congruent to each other. So again, a rhombus is like a parallelogram, and that opposite angles are congruent. But then also we know if angles are next to each other, they have to add up to 180 degrees. They have to. So if this one here, let's say would be 100 degrees, automatically we know that this one is 100 because whenever they're opposite of each other, they have to be congruent, right? And then whenever they're next to each other, consecutive angles, they have to add up to 180. They have to be supplementary. So if this is 100, this has to be 80 because again, they have to add up to 180. And if this is 80, that's 80. Okay? Just always remember, when it comes to a rhombus, all the angles are the same characteristics as a parallelogram. Opposite angles are congruent, and consecutive angles add up to 180. But when it comes to a rhombus, all the sides are congruent. They're all the same, right? So knowing this, let's actually analyze and apply them to be able to figure out unknown measurements and all that, right? And all of this is dependent on the fact that they always have to tell you what figure you're working with. So the first one, I'm going to tell you that we're working with a rectangle, right? The figure that we're going to be analyzing right now is a rectangle. And all I'm going to want you to do, I'm going to want you to end up solving for a variable, right? So I'm going to tell you that this here is 4a minus 10, and I'm going to tell you that the bottom side is 14. We want to solve for a, and it's a rectangle. So since it's a rectangle, we know that the top side and the bottom side are equal to each other. So if they're equal, we can write that out, right? We know that 4a minus 10 equals 14. Because again, what we know is the side on the top and the side on the bottom are congruent. They're equal to each other. So 4a minus 10 equals 14. Because once you have that, now it's just solving it, right? Anything with the variable, save for last. Let's get rid of the 10 first. Opposite of subtraction is addition. Add 10 here. The 10's cancel out. We're left with 4a equals 14 plus 10 gives us 24. Now in order to get a by itself, opposite of multiplication is division. Divide that by 4, divide that by 4. So we have a equals 24 divided by 4 gives us 6. And there's our answer, right? And we're not saying that the side is 6, we're saying that a is 6. Because now if we wanted to substitute a, we can do 4 times 6, which is 24. 24 minus 10, 14. Same thing. Again, it's that idea of applying the properties of what we're doing, right? The next one, we're going to end up analyzing it in terms of being a square, right? And again, it is important that they always tell us what we're working with. Next one is a square. So knowing that the next one is a square, I'm going to want to find certain measurements, right? I'm going to end up telling you that this here is 9 centimeters. I'm going to want you to solve for h, and I want to figure out what k is, right? So since we know that this is a square, automatically all the sides are equal, right? So if all the sides are equal, if this is 9, we know that h has to be 9 centimeters, right? Because again, it's a square. So that's 9. And k represents an angle. Since it's a square, we know that all the angles are equal to 90. So if all the angles are equal to 90, we know that k equals 90. Because whenever it's a square, again, it's always right angles, right? All of them are always right angles. And when we have right angles, we know it's equal to 90 degrees, right? Idea of a square. The next one too, I want to use it again, knowing that we're working with a square. But now it's going to look differently than what I'm going to ask you guys to solve for. Again, we have a square. We know that all the sides are congruent. We know that all the angles are equal to the same thing, right? I'm going to make this here equal 10x. So I'm telling you that this angle there is 10x. I want you to solve for x. I don't give you anything else, and some people will look at this and say it's not possible, right? But we know that it is, right? There are two ways that people would do this. One, since it's a square, they know that each angle is equal to 90 degrees, right? And using that idea, some people may do this hard, some people may do this easy. Some people would say, you know what, I can just add everything. 10x plus 90 plus 90 plus 90 equals 360. Technically, if I wanted to do this, I could. It'd give me a lot of work, but yes, if you wanted to do this, you could, and it would give you the right answer. You would combine like terms, subtract, and then divide by 10. You can also focus on the fact that since all the angles are 90, we know that this angle here is also equal to 90 degrees. So if that angle is equal to 90 degrees, we can just do 10x equals 90. Because it's that idea. If all the angles are right angles, are all 90, then this angle here is 90 degrees too. So we know that 10x equals 90. And now in order to solve for x, Get rid of the 10. Opposite multiplication is division. Divide that by 10. Divide this by 10. X equals 9. And it would just be that. Because now if we wanted to substitute it, 10 times 9 gives us our 90. And again, if you wanted to solve all this, you could. You don't need to. But 90 plus 90 plus 90 would give us 270. If you were to subtract 270 from 360, it would end up giving us 90. So we would literally have 10x equals 90, which is exactly what we had to start. Same idea. So you can do it the complicated way, and then you would solve it, divide by 10. If you do it the complicated way, you would just see that it's equal to 90 from the beginning. And then the last one I want to do is just focus on the idea of a rhombus, which again, same idea for the most part as a parallelogram in regards to the angles. We know that the sides of a rhombus are the same as the sides and the properties of a square, just for the sides, okay? A rhombus. Now, if I give you a rhombus, and notice how we don't have to give all the angle marks, all the congruent marks, because the second that they tell you the name, everything is true right about it. So if this is a rhombus, I'm going to make that A, I'm going to make this one B, I'm going to make this angle 115 degrees, I'm going to make this C, D, and E, and then I'm going to make this side here 3 feet. Okay? And again, it's complicated, all that, but since it's a rhombus, start with the easy part. If it's a rhombus, all the sides are all the same. So if that's 3 feet, we know that A is going to be 3 feet, right? We know that B is equal to 3 feet. We got those two. Now we know with the angles, just like a parallelogram, opposite angles are congruent. So if this is 115, we know that D is going to equal 115 degrees, right? We got that right there. Because again, opposite angles are congruent. Now, we know whenever we have angles next to each other, consecutive angles, we know that they are always going to add up to 180. So if this is 115, the way we figure out C is 180 minus 115, which gives us 65, right? So we know that C is equal to 65 degrees. And remember about opposite angles. If this angle is 65, we know that this angle here has to be 65 as well. Again, it's a lot of numbers, guys, but always remember, opposite angles are always congruent, opposite angles are always congruent, and whenever they're next to each other, they always add up to 180. Just remember, guys, properties of parallelograms, squares, rectangles, and rhombuses. They have a lot of things in common, but they also have a lot of differences. Any questions, feel free to ask. Take care, guys.